When we talk about unidirectional data transmission, one major value of our software is we offer a consistent proximity data exchange across platforms, meaning businesses that use Radius are not limited to their implementations, and their client bases are not limited to OEM-specific transaction methods. 3.0 supports iOS, Android, Linux, Raspberry Pi, and Windows. Previous versions are currently available on macOS, React Native, as well as our web SDK beta. With unidirectional data transmission, a few things must be true. A device with a speaker and a microphone must be present, one to act as a transmitter and one to act as a receiver. You must have a frequency response of at least 20 kilohertz on those components to ensure that the signal can be transacted and demodulated. You also need to make sure that you have an application that can leverage the Radius SDK integration. Once installed, the application must have microphone permissions accepted for any application that's going to be leveraging a receiver. And this is not required for any application that is only going to be used to transmit data. Some of the key Radius SDK objects are transmitters, receivers, and tones. And a few key parameters are the SDK token, which is used to initialize and validate the SDK, our tone profiles, which we'll talk about next, and the data payload itself. Now, data can be structured or unstructured and be whatever data is needed to facilitate a transaction. This can be verification data, a user ID, a loyalty ID, a tokenized card, transaction ID, location ID, the list goes on. Leveraging these components together, there is no need for cellular data, Wi-Fi, or any connectivity to send data between devices. Phones can be in airplane mode and still work just fine. At no point will the technology record any audio or intake human speech, nor does it store any data. We also have a tone service API, which can be used to generate MP3 or WAV files embedded with Radius compatible tone payloads. This may be useful if your platform is not supported, your mobile application has size limitations, or you would like to broadcast from a standalone device, such as a speaker or an intercom system. We'll transition into bidirectional communication next. And with bidirectional data transmission, a few inputs come into play with our Radius transceivers and take the concept of online to a different level. Transceivers allows for simultaneous data transmission in both directions between devices with speakers and microphones. This is done with a combination of setting a transmitter profile and a channel on one transceiver to align with the receiver profile and channel on the opposite receiver, transceiver, I should say. This can be seen in the red and the blue objects in the diagram. Some common applications of leveraging transceivers include location beacons, acknowledgements, and any use case requiring a handshake or a round trip verification. And this is independent of industry or sector. So next, I want to transition into our tone profiles. But before we jump into the details of our tone profiles, I do want to give some general background knowledge on sound waves. So sound waves are sine waves that have three main components that define it: frequency, amplitude, and phase. Frequency is the number of complete cycles per second, and it has a direct correlation with pitch. Amplitude is the deviation from the center line of a wave to its peak, and phase is just a fancy word for angle. So Radius 3.0 has three tone profiles that were all designed to solve for data transmission at varying distances and varying transmission speeds, and are broken up into two separate tone families. That's zone and point. Now, there's a lot of digital signal processing detail that I can get into for our tone profiles, but we won't include that in our presentation today. But for the sake of grounding us on how Radius leverages sound, zone uses FSK, or frequency shift keying, where tones transmit data using the frequency of the wave and involves easier algorithms and has less computations. Our point uses PSK, which is phase shift keying. And this is where tones transmit using the phase of the wave and involves much more complex algorithms and computations. Our tone frequencies sit anywhere between 16.5 and 19.5 kilohertz, depending on the channel that's selected. And for context, the average adult can hear frequencies between 0.02 and 16 kilohertz. And the frequency of me speaking right now is somewhere between 2 and 4 kilohertz. Hearing a tone is compared to ambient background noise for comparison. And our high frequencies are how our tones can survive very noisy environments, independent of how loud it feels to us as humans. So simplifying the diagram, Zone 66 is primarily used for longer range transmissions with smaller payloads, and 0.1000 and 0.2000 are used for short range transmissions with much larger payloads. So I want to jump into a few examples of unidirectional transmissions. So leveraging what we just learned about our tone profiles, we want to put them into practice a little bit and walk through the flexibility of how a bunch of unique experiences can be triggered with our Radius 3.0 SDK. So for the sake of understanding, any examples you see a MPOS, it represents a merchant, and all phones represent the consumer. If you see a sound wave icon, it represents a transmitter. And if you see a microphone and a check mark, it represents a receiver. I'm going to showcase a distance visual to give a better perspective of the applications as we work through each of these examples. So at 3 feet, a data transmission using zone or point could represent a payment request, a ticket validation, or access control as an example. At 6 feet, a data transmission using zone could represent sending a transaction ID at distance, and this could be in a BOPIS scenario or a locker pickup code as another example. At 14 feet, a data transmission using zone could represent a store, service desk, deli counter, or a pharmacy location. Think about a loyalty check-in in any of these scenarios. And this also allows improvement to the merchant with their efficiency by knowing exactly who is at the store or at the counter. Next, we'll talk about 25 plus feet. A data transmission using zone could represent the functionality of a live event or a proximity marketing example where tones are transmitted through a more robust speaker system. So to dive into a few examples in our past, in our experience, broadcast television, for example, has shown high user engagement numbers in live deployments. We've seen highly targeted engagement numbers on insights such as user reach and average time watched. In live event and stadium deployments, engagements based on proximity messaging via notifications, promotions, as well as proximity gamifications have created millions of brand impressions and user engagements, where other modalities tend to fall short across that level of variety of use cases. Having the ability to transmit data in short or long ranges paired with small or large payloads truly allows our customers to be creative and strategic about how they can drive engagement with their customer base. So we'll transition from unidirectional to some bidirectional examples. Now, with bidirectional, we bring in this concept of transceivers, and you'll see a few new screens that will now represent what is called two-way data exchange. So in these examples, at 3 feet, a data transmission using point could represent access control or a ticket validation with a return acknowledgement to the access hardware. Starting at 3 feet and then moving further away, a data transmission using point and zone could represent a payment with an additional localized acknowledgement from the merchant when network data connectivity could be an issue. At 14 feet, a data transmission using zone could represent a long-range P2P data exchange between consumers. This could be a payment request and response, social contact exchange, or many other examples using this particular implementation. And at 25 plus feet, a data transmission using zone endpoint could represent a transit infrastructure where tones are transmitted through existing speaker systems that trigger additional experiences and accesses. This is all by leveraging the power of bidirectional communication. So staying on the theme of high engagement and efficiency, we do have some examples in the mobility sector where onboarding density is a problem. Radius is being looked at to increase system throughput minimums by 40% or more. Radius is all about delivering and creating high-level engagement as accurately as possible, is accessible, and it's very scalable. As we compare our technical modalities to Radius, a few things stand out. NFC is captive with range and is hardware dependent, with OEMs controlling the data. Bluetooth configuration could trigger low levels of engagement with BLE, and it's susceptible to RF signal bleed. One of the benefits of the physical properties of sound is it's easily adjustable and it can be contained by physical barriers, meaning a signal is not going to go through walls and it can be contained in the space that it's required to remain. The Radius SDK allows for programmatic volume control in instances where calibrating the transmission for very unique environments is required. QR codes lack security and bidirectionality. Wi-Fi has low engagement barriers with friction connecting to networks, as well as dead zones. And ultra-wideband has limited availability due to infrastructure where ultra-wideband devices aren't available. In many cases, it's not always the technical modality, but the limitation of the implementation that drives low engagement. As the market continues to validate viable solutions, a concept or a saying we acknowledge here is no one gets fired by hiring IBM, but also no one gets fired when it's a proven example of a technology that works. Buyers have used LISNR Radius at scale and have justified it to buy it. While not at the same name recognition of an IBM yet, again, we have 34 patents across 13 patent families and 13 additional 100+ patents filed and pending. Customers in the field see the value we bring, and we're gaining traction as a proven solution around the globe.